All right, day 7. This is a super late one, and quite a few glasses of wine deep. So let's see how this goes. Day 7. So, camel cards. Your all-expenses paid trip turns out to be a one-way 5 minutes ride in an airship. At least it's a cool airship. It drops you off at the edge of the vast desert. Okay. Did you bring the parts? He asks. Did you bring the parts? She asks again, louder this time. You aren't sure what she's looking for. The parts for the sand. Yes, come with me. After riding a bit across the desert island, you can see what looks like a very large rock covering half the horizon. Yef explains that the rocks are all along the part of the desert island that is directly above Island Island, making it hard to even get there. Normally they use big machines to move the rocks. But the machines have broken down. Desert Island recently stopped receiving the parts they need to fix the machines. You've already assumed it will be your job to figure out why the parts stopped. You agree automatically. Because the journey will take a few days, she offers to teach you the game of camel cards. Camel cards is sort of poker. Alright, well, I should be pretty good at this. Except it's designed to be easier to play while riding a camel. Of course. In camel cards, you get a list of hands, and your goal is to order them based on strength of each hand. A hand consists of 5 cards. Okay, that's different from poker then. Yep. You can have a 5 of a kind, 4 of a kind, a full house, a 3 of a kind, a 2 pair, a 1 pair, and a high card. Okay. No types. That helps. Hands are primarily ordered based on type. For example, every full house is stronger than any 3 of a kind. Yep, that makes sense. If 2 hands have the same type, a second ordering rule takes effect. Start by comparing the first card in each hand. If these cards are different, the hand with the stronger first card is considered stronger. If the first card each hand has the same level, however, then move on to considering the second in each hand. If they differ, the hand with the bigger second card wins. Otherwise, continue with the third card each hand. Yeah, so if you have a pair, then you and they're the same pair, an ace and an ace on both. Then you move on to the kicker, and then the kicker's kicker, and then kicker's kicker. Yeah. Yep. Yep. Right. So 3 3 3 3 and 2 ace are both 4 of a kind. Wait, it's stronger because its first card is stronger. Wait, what? What is this? How does the 4 of a kind ace not win? So the 4 of a kind 3 and the 2 is stronger because its first card. Oh, okay. Okay, so it's very different from poker then. It's like the literal first card. Similarly, 7 7 8 8 8 and 7 7 7 8 8 are both a full house. Okay, let's see if I can figure this out. In full house, but 7 7 8 8 8 is stronger because the third card is stronger, right? So it's quite different from poker. You're given a list of hands and their corresponding bid. Your puzzle input, for example, this. It shows 5 hands. Each hand is followed by its bid amount. Each hand wins an amount equal to the bid multiplied by its rank. Okay. So 1 pair, 1 rank, 2 pair, 2. And then, wait. 2 pair, their first card both have the same label, but the second card is stronger, so gets rank 2. Oh, like, do you actually rank these as in, like, okay, I see. So that is first, and then 220. That's the... Wait, this is first? Rank 1. Oh, rank 1 is in the lowest. And then this 2 pair, Jack, 10, 10. But there's a 2 pair here with a king, and then the king. Yeah. That's interesting. Find the rank of every hand in your set. What are the total winnings? Alright. Let's do it. Let's do this. So there's a couple of ways of doing stuff like this, I think. There's a couple of ways. You can do dynamic programming, where you figure out every hand's position. That seems like a really big map, especially because you can't sort it. And you can't sort it because the order matters. So I don't think I'll do that. So what I will do is I'll do functions for all of these. For these, yep. And to determine the rank. So function get rank, get hand, which will take in cards, which is an array const u8, and just to really get ourselves, if cards dot length is not equal to 5, we're actually going to panic. Cards should always be 5. just you know, a little assertion so we don't get ourselves in a kerfuffle. Okay, so the first thing we need to do is we need to check for a 5 of a kind. And these are probably done as best as individual functions. 5 of a kind, which is cards const u8, and this is a boolean. For cards C first card is equal to cards 0 if first card, if C is not equal to first card, return false. Return true, so they should like be equal to that first card. Function for of a kind, which takes in cards, const boolean var same card count. The way we could do this is guess we could have a map. Const pay allocator should standard.heap.allocate. I guess we're not really that bothered about, you know, leaking some memory. Last in cards is equal to standard.hash map auto hash map between u8 and u32. It's just u8 even, doesn't need to be very high. Dot init, just the allocator. The firm allocator dot free. Can I not do that? Do I have to declare it here maybe? I have to declare it every hour I want to use it. That's kind of annoying. Allocator dot no. Page allocator. Free same cards. Alright. So for cards C, same cards dot put. You can be you have to be able to throw errors. We're gonna put C. Actually, we have to check if same cards dot get C and if num, then we try same cards dot put C num plus 1. And let's do an else instead. Makes it a little nicer. All right, and we should do the same. for 4 of a kind, this is actually fairly easy. We can say car and same cards dot get cards 0 is equal to 4, or same cards dot get cards 1 is equal to 4. So like one or the other. At least we need 4 of the same type. Yes, that's 4 of a kind. Full house. 3 cards have the same label. Full house. Cards. Cards U8. Bool. And let's just copy a bunch of this stuff here. Same sort of logic. We're gonna do if same cards dot I kind of want to see the keys. Iterator? I guess we could. Iter equals same cards dot iterator. We're going to capture the entry. Far times u size equals 0. Each time we go around, d plus or equal 1. Basically, I want to know the keys, right? This is going to have 2 keys. We don't need times here. Key 1, which is a U8, is, yeah, I don't know, dot. That should be a pretty inoffensive one. Key 2, if key 1 is equal to dot, we'll do key 1 dot, key 1 is equal to entry dot key pointer. Continue. If key 2 is equal to dot, what we're going to return is if we get actually a full house is just a 3 of a kind and a pair. 3 of a kind and a pair. So actually we probably don't need this one that much. Full house, 3 of a kind, 2 pair, 1 pair, then high card. Let's do that, 3 of a kind. Which is where we do much of the same, and we even grab the iterator here, and what we do is while iter dot next entry, if entry entry dot value dot star is equal to 3, we just return true. If there is a card with 3, great. 2 pair cards you very much similar things. Yeah, I guess we're not going with the dynamic programming approach, which could come back to hurt us, but you know, it's late. Let's just continue. I'm assuming this just works as well, so that probably works. To counter U8 0, to counter plus or equal 1. If to return to counter equals true. Two individual pairs. Function pair. Oh, this is not 3, it should be 2. It's not 2 counter, it's pair counter. I'm not sure it's worth making the distinction, but turn pair counter is equal to 1. And what we're assuming is that we're going to call the very highest one first to get it out the way, and then proceed down. And we were in a full house, weren't we? We were in a full house, and basically here full house is interesting. I think we can just do return 3 of a kind, and again we have to like try cards and try and a pair is exactly 2, not 3, so that doesn't count as a 3 of a kind, and pair of cards. Okay, let's just make sure you compile. Great, compiles, everything's fine. Get hand. Okay, so now what we can do is we can say we return a U8 of a kind is equal to 5 4 full house 3 of a kind 2 pair and pair high card 0 1 2 3 4 5 and then 6. I'm going to return if here it just returns high card. Comp time int. Maybe we don't want comp time int. I mean, maybe let's see what 6 says. If 5 of a kind, return 5 of a kind. Four of a kind, 4 of a kind, full house, 3 of a kind, 3 of a kind, 2 pair, 2 pair, 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 and then otherwise returns high card. Okay, cool, we have some cards, and I guess the first test we need to do is to determine them. Let's take each one, split it. Okay, so for input line, we want to tokenize on the space. Well, tokenizer equals standard.mem.tokenize sequence U8 line and on space. So var cards equals tokenizer.next question mark bid, which I think we can ignore for now. Let's actually do underscore that. Standard prompt print equals standard dot print. We're going to print card, hand. You can print cards as well, I guess. This is an any, and then the hand, just I think that is fine. What we do is print cards and then get hand of cards. Alright, what's wrong? and then try. I think 5 of a kind is the only one that doesn't throw, so you don't need to do that. Where is this? This is a try there. Oh. Access of union field pointer while field struct is active. Oh. Oh god, what is that? What is that, I wonder? No, I'm not sure. Let's just comment these out. Do you run? But if I uncomment this, I don't think you run anymore. I have a funny way of getting around that. Don't free. Yes, guys, let's you know, the operating system has a way to claim back memory for a reason. So let's let it clean up the memory, and you know, if we can leak some memory, it's fine. So let's have a look at the inputs. 32T. Maybe we don't want any, just S. Yeah. That has rank 1, which is pair. It has a 3 and a 3. This has rank full house. No, 3 of a kind. So we have pair, 2 pair, full house. Yeah, 3 of a kind. This has 2 pair. This has 2 pair. One has 3 of a kind. Cool. Nice. I guess we also need a function that takes in cards 1, which is an array of U8, cards 2, an array of U8, and basically I just want to say which one is bigger. Well, true equals cards 1 is better. False equals cards 2 is better. Function tie break. For 0 dot cards 1 dot length and 0 dot wait, we can do cards 1, cards 2, C1, C2. If C1 is equal to C2, continue. If C1 is bigger than C2, then true. Oh, here we just return if C1 is bigger than C2. Right, cool. Then we have a tiebreak function. Anyways, what are we doing? Okay. Yeah, we want to get their rank, so we want to calculate like their thing. Their oh god. Their strength, and then we want to tie break them. Oh. Yeah, that's not straightforward at all, to be honest. Because we need to collect all like cards, and then we need to go through every combination for a tiebreak. Oh, is that where part 2 is going to get you? Where, oh, that's not nice. Basically, we want to order them based on tiebreak. Ah, right, I see. I mean, okay. Okay. This is not terrible. How big is the input? Oh god. There's gonna be so many tie breaks to be done. Maybe... I think this is definitely like a sorting algorithm based on the tie break function. But you know what, for now, what I'm definitely going to do is just going to do page allocator equals standard.heap.page allocator. Just call you just allocator. We're going to have var hands map equals standard.auto hash map, and you're going to have a type of like urate, and you're going to go to an index, to the index of inputs. Yeah, that looks right. Dot init allocator define allocator dot free hands map. Cool, great. What we're gonna do? Oh, but we want buckets. We want like basically like an array list for each one that we can then sort. All right, that shouldn't be too bad. 5 of a kind list, which is standard dot array list of type. Let's say usize, because 4 of a kind list, 4 house list, 3 of a kind list, pair list, high card list, 5 of a kind list, 4 of a kind list, full house list, 3 of a kind list, pair list. There we go. Okay, we have some maps. And what we're going to do, var hand equals try get hand of the cards. And yeah, and then we don't even need that there. Oh, am I gonna have to do an if statement here? Oh, I don't really want to. Oh, I know what to do. Var cards hands equals allocator dot alloc, and we're gonna alloc a U8. We want 6 of them. Oh, if I remember, let's have a look at how we did this earlier. I remember we had, oh, you can just say this here. I want an array of 6, which are pointers to array lists of usize. And the 0th is going to be the high card list. After we have the pair list, after we have the 3 of a kind list, after we have the full house list, after we have the 4 of a kind list, after we have the 5 of a kind list. Okay, 1, 2, 3, 4, 5, 6, yep. Standard dot. And what we do is we keep them like that, and we can say hands at the hand dot star dot append cards. No, the index 0 dot high Rerun. Error is ignored. Correct. Is this defer? Like, really? No deferring for anyone. No defers. There you go. We leak memory. We're just gonna leak memory. Alright, so what we should then do is, well, we know that the high cards are going to be not great. And we could take their bids. Here we're gonna, is there a sort method? I do wonder. Hand dot sort. Oh no. Zig learn. Let's have a look at sorting. Sort. No. Sorting. There we go. Standard.mem dot sort. Okay. The user must provide their own comparison function. Ooh, how do I do this? This is interesting because I definitely want my own comparison function. Zig sorting comparison function. Context in sort function zig, maybe? Okay, yeah, that's the compare there. And they have sort comp time. Right, maybe that just works. Okay. Okay, so then for hand, for now we could, hand, we could go for just the 2 pairs. They're the only ones that repeat, so we have a 2 pair here and here, so the 2 pair is 3. So we could say well, 2 pair slice equals hands at 2.2 own slice. Alright, we have a slice standard.mem.sort, and we're going to sort yeah, now this is not that great. Instead of use sizes, maybe we could do pointers. That's basically what a use size is, right? Okay. Okay. So the type of that comp time function, left hand side t, right hand side. Yeah, okay. Function type break from inputs. So it's going to have an input of this, cards 1, C1, which is a use size, C2, which is a use size. It's going to return bool. And what we're going to do is we're going to say cards 1 equals input cards 2 C2 and tokenizer 1 equals standard.men.tokenize sequence U8 cards 1, cards 2. Okay, and then cards 1 of our, what should we call it? Running out of names. I'm gonna call this one line 1, line 2, line 1, line 2 for card 1, which is equal to tokenizer 1 dot. What are you complaining about? Tokenizer 1 dot next dot question mark. That's 2, tokenizer 2. Alright, great. So now what we can do is we can say return the tie break between card 1 and card 2. Okay, that might work. And I hope this sorts in place. Must do, right? Twin slice, this is a U size. Items are the 2 pair slice. And then context of any type. Input. And then the comp time, which is tie break from input. Ooh, I don't know if that works. That seems tie break. Return true. Okay. Okay, that seems to have worked somehow. Okay, 1, 2, 3, 4, 5. 5 of a kind slice. 4 of a kind slice. 4 house slice. This is going too well. This is going too well. I'm very suspicious. This is 6, this is 5, this is 4, this is 3, this is 2, this is 1, this is 0. I'm going to sort them all. 2, 3, 4, 5, 6. 5 of a kind slice. I love the amount of memory we're making right now. 4 house slice. 3 of a kind slice. Pair slice. High card slice. Two pair slice. And what we're going to do is we're going to take the bids. We're going to take the bids. And we're going to return them the ranks multiplied. So what we can do here is, well, we can start with the high cards. We can start with the high cards. And let's put them in an array. Slices, which is equal to an array of 6 of pointers to use size arrays. Is this it? Maybe I need a bracket here. Maybe that's it. Okay, and we have the 0 goes to a high card slice. our pair slice, then our 2 pair slice, then our 3 of a kind slice, 4 house slice, kind slice, 5 of a kind slice. Here we go, 4 slices, R, and then we go 0 dot dot, and we go I. What we can do is we can say if I is equal to 0, we're going to treat you differently. We're just going to say part 1 plus or equal to, oh, we need the bid, let's get the bid. Tokenizer equals standard.mem dot tokenize secret. I hope this isn't that bad. Input for array dot star is an array of view sizes. J for hand equals input at J. Tokenize the hand, line our hand is equal to, oh, we don't, well, actually we don't even care about the hand, we just do tokenizer dots. Next, that's question mark, bid equals try standard.fmt.pass int as a use size, and this is going to be tokenizer.next dot question mark and 10, and if I is equal to 1, we have to go plus or equal to index plus or equal to the index times the bid, otherwise var size is 0. We don't even need this extra if statement. Just makes for better programming. Count plus or equal to 1. So now we do counter, but it does start at 1. No, we don't even need you, and might not even need you. Count plus or equal 1 each time it goes around. Print part 1. We haven't done a lot of testing. So, you know, I'm gonna get very suspicious. Try what? Hand 6. So hands 5 of a kind, 4 of a kind, full house. Oh, we don't have a 2 pair. 2 pair list. No, that's better. It's actually 7 items, just like there. We're tokenizing our space. Is that right? This would be such like all right, fair enough. Yeah, that seemed way too good, right? Like, Jesus Christ. Can you imagine we got that just first try? Yeah, I mean, so that does work. 6, 4, 4, 0. But that seems like a really lackluster input, to be honest. Yeah, it's quite like lackluster, so I think I'm gonna make my own. I'm gonna make like A of 1, king, 2. Let's start there. So we should expect to see 2 5 of a kinds, and this ranks higher than the other one, so it'd be 1 times 2. So let's make our numbers, I guess, make it easier. So this would be rank 1, 7, 6, 5, high card, no, pair. Yep. So this here would be rank 1, so 2 times 1, 2, and then this 5 times 2, 10, so 12 I should see. 12 I do see. 12, but then what if we have A 8, A 9, and an 8, and with a 2 then, so we should see this being rank 1, so 5 times 1, and then 2 times 2, 9. We should see 9. We don't see 9. We don't see, should we see 9? So this gets rank 1. This gets rank 2. Yeah, absolutely we should see 9 there. Test type break. Expect the standard of testing dot expect. Try expect type break of type break of A9. So basically I want the first one to be better. Currently it seems like zig test slash source day 7. Okay, no, it does pass. That's correct. So it must be the sorting. Let's before this print full of a kinds. Any. For a kind slice. Oh, not test, just run. What is this? Invalid format use size. Just do any then. So it goes 0 is the strongest. Do I need to invert? Maybe the sorting. Like this. So C10. Maybe it's that. Okay. No, but now that gives me a wrong answer. 6440. Okay. Let's just reread those tiebreak rules. So these tiebreak rules, they're both 2 pairs. Their first card both have the same label, but the second card, this one is strong because of the K. Oh. think we need to account for that. Like, because we need to definitely account for those. Yeah, because they're not numeric values. So, if C1 is so they're not equal. C1 is equal to king. And they're not equal. Let's return true. If C2 is equal to king, return false. If, I think we need to do this just like a couple of times too. So king, 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 king. If this is a queen, then return true. If that is a queen, this is a jack, this is a jack, and also a 10, right? Because a T, which is a 10. And then you go back to normal. Oh wait, why have I just broken that? They're not equal, that's a king, that's a queen, that's a jack, that's a 10. I have just broken that, and if I comment this out just to make sure that that is what breaks it. Yeah, that is what breaks it. Go this way. It's funny. Interesting. Let's have that. Yeah, I don't. Okay. Yeah, okay, and yeah, so this is where it fucks up. Right, this should be correct. So it's the two pairs. Zero and two. So apparently this one here is stronger than that one. Wait. Wait, that makes sense, right? That actually makes sense. I don't think it would change if I do this. If I just invert all that. So basically the opposite of what I wanted. So yeah, because I think we got some ascending order errors here. Just let's see. Do we strike gold? That looks suspiciously similar. No. Yeah, that was kind of hopeful, wasn't it? 9, 2, 8. Okay. And let's make you 5. So this should have a high rank. So 2 times 2. This should have the low rank. 5 times 1. Just give me 9. Should be 9. Okay. double check our tie break. False, true, false, true, false, true, false, true. Interesting. Okay, well let's type some inputs. Let's try some stuff, I guess. Let's try 2 pair, 2 2 AA, 3, king king, 2 2 3, 2 3. Let's try some full houses. King A, king A, king. And let's do king, 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 2 2 7. So what should happen here is the full houses are highest. This one wins because it has the second card there. So 5 times 1 plus 5 times 4 plus 7 times 3 plus that one there, which is 3 times 2 plus 2 times 1. 49 is what we should see. 49 is not what we get. Okay, that's something to look for. 2 pairs. Full houses. So the 2 pairs 0. 0 is stronger. Now I need to get my order right, because the ones to the right, if you're on the right side there, that means that you have a higher index, so you have a higher rank. That's correct. Top one there is correct. The second one, 2 and 3. No, that's no longer right. This here and this here. I think I was probably right about this here. True, false. Let's do that like that. So, but now that swaps over this top one. It gets, says that 3 is first. Oh no, that was right. That was fine. I think that was fine. 2, 3 is the highest. No, yeah. No, 3 is not the highest. 2 is the highest. Interesting. But I guess this is fine. 0 is the lowest, and then this is higher. Interesting. Like, so I guess king, king moves on to the next one. That's interesting, isn't it? So basically it thinks they're in order right here. Just this tie break here doesn't like it. Looks like I don't have the ace. I don't have the fucking ace. That's correct. I do not have the ace. All right. There we go. Let's go. I feel like we haven't suffered enough for that. That seemed like relatively straightforward. To make things a little more interesting, the elf introduced one additional rule. Now J cards are jokers, wild cards that can act. Oh no, please no. Wild cards that can act like whatever card would make the hand the strongest type possible. To balance this, J cards are now the weakest individual card, weaker than any two. The other card stay in the same order. Okay. J cards can pretend to be whatever card is best for the purpose of determining hand type. For example, Queen, Joker, Joker, Queen 2 is now considered 4 of a kind. Man, are you serious? I just don't want to deal with this. I mean, fine, this isn't terrible. What I do want to do is do a tie break for this part. Okay, let's just start folding. Tie break part 2, which now takes the jack out of the equation. But actually, what we need to do is check if C1 is a jack, then we return true and false like the inverse because it's the weakest. So that's great. And what we're going to do is we're going to sort them again. I'll zoom in a little bit. We're going to sort them again. I'm going to sort them again right here. But we're going to do tie break from inputs, part 2, tie break from inputs, part 2, tie break part 2. Tie break from input, tie from input, part 2. Great. I'm going to sort them again. Oh no. No, we can't do this yet because we need to get the whole thing here. So basically what we're going to do is we're going to still check everything here basically. Right, we're going to check. Yeah. But if I need like need to write something. So there's a couple of scenarios you can have. You can have jack, 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 jack. Okay, so this is just 5 of a kind. Okay, you can have jack, 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 jack. Random card, I'm going to use ace, and this is also 5 of a kind, and the logic for this here is I guess a little bit more special. This is going to be if for jacks, then instant 5 of a kind. That's one of them, and then there is going to be jack, 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 ace, ace. This is interesting. If full house and 3 jacks, then 5 of a kind. Yeah, then becoming wild cards is a really cool, interesting part too. I'm wondering. Yeah, we can have jack, 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 a jack, a king, this would be a 4 of a kind. But then you'd have to turn it into the strongest card, which is the ace. Oh no, you don't need to turn it into anything. You just say 4 of a kind. Okay, that kind of finishes that off. Jack, jack, ace, ace, ace. 5 of a kind. So basically, there's a logic. If only J and other types, then 5 of a kind. Right? Okay, so what I'm going to do is I'm going to write 5 of a kind, Joker. You write. Here we're going to try bool, and you're going to be, you can throw an error just in case. And actually our get hand is going to be just changed slightly. Okay, and it's going to do a thing like this. I'll put down a function. Yeah, count cards. And that's going to give you cards. It's going to return standard.auto hash map of u8 to u8. Maybe the pointer to said thing. And then definitely we don't free. Let's do this and return the array of same cards. 5 of a kind Joker. Bar cards is equal to try count cards. Stick in cards there. Okay. So what we're going to do is we're going to ask if so anytime we call at least one Joker, right, at least one Joker. So if there is at least one Joker, to be a 5 of a kind with a Joker, you need only 2 card types. So, can I do cards.size.key dot count? Hello equals hello dot. Oh, ye32. We're going to return. I'm guessing that gives you the right thing. Cards.count. So is equal to 2. Oh, C. Okay, and then function for a kind Joker takes in cards, constituate. So var c is equal to try count cards. So the 4 of a kind, this happens when it is not a regular 4 of a kind, but for it to be a 4 of a kind, so some valid ones. Jack, 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 a king. Jack, 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 ace, king. So there's 3. 3 jacks. Yes. So we need to count for 3 jacks. if c dot get the jack, it exists. Actually, no. If it goes into here, it always exists. Right, let's be safe. Let's be safe. We need to ask how many jacks there are. Or is it if there's only 3 types of cards? Like if you have an ace, ace, king, king, jack. Yeah, that's going to be 3 of a kind. So we're going to ask if the card count is just 3. So, okay, let's make the assumption that going into these 4 of a kind jokers requires you to have a jack. We can actually affirm that. We can do count cards. Yeah, by doing this little guard here. Okay, so if there is a jack, then we return c that count is equal to 3. Okay. Function full house joker. Let's take the same guard and also to here. There exists a jack. 2 times equal to 2. Because we're going to check the other ones first. We're going to do try the other one, or the other, or this one here. Okay, and then full house joker. Okay, what will this be? So, for example, joker, 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 king, king, joker, 2, 2. Because this might make the 4 of a kind not enough. Yeah. Alright, so I just had a quick think about this, and it turns out we don't have to do that many checks. I have kind of just written a page on a notebook, and I was thinking this problem, surely we reuse some of the stuff we already have, and we do. So, for example, the 5 of a kind joker, we guarantee there's a jack. What we do then is we just say, well, are the cards a regular 4 of a kind? That's it. Return try. Let's return that. Because it's a 4 of a kind, and there is a jack. Either all the jack, or either there's 4 jacks, or 4 of any other card and 1 jack. You're right, Zimba. You're a good boy. Yeah. So then, 4 of a kind joker. 4 of a kind joker, there is a jack. What we do after, enter it down. 4 of a kind. So basically, if it is a 3 of a kind, if it is a 2 of a kind, or a 2 pair, kind of. Oh, this one's a bit strange actually. Because here are the examples I wrote down. So we can have ace, ace, king, king, jack, and that's not true. That cannot be allowed. But what can be allowed is ace, 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 jack, king. Yes, that can be allowed. So the way we have to ask this is there 3 cards Or even, is there a three of a kind? So that's like an easy one. Is there three of a kind? Right. Is there a three of a kind? We can try. Is there a three of a kind? Anywhere, because if there is and there is a jack, then that's just instant. If there isn't a three of a kind, then we can ask for a two pair. And we can return one of jacks if there is a two pair, but it has to include the jacks. So, or try two pair. It's probably the sketchiest one. And num of jacks is equal to 2. Sketchy, but let's see. Function of full house with a joker. Full house with a joker. We're going to, first of all, we oh god, where am I? We're going to do the guard here to see if there are any jacks, because we don't want to get mistaken, just in case. Okay. So the full house happens when you have ace, ace, king, jack, or you can have ace, king, 2 jack. You can have a three of a kind, because if you have a three of a kind, then you're going to go into the four of a kind straight away. So we need to check here. What's you on about? What are you on about? Redeclaration of full house joker. Oh, my bad. Is if you have a two pair, or actually just a pair, right? If you have a single jack and you have a pair, we can just say, can we just say if you have a pair? Any pair works. King, the other ones don't matter. The jack turns it into, no, does not turn it into a full house. You need two pair. Yeah, you need two pair, I think. Oh, might have to think about that one again. Return, try to pair the cards. I'm not super convinced. We might have to like come back and retry our logic there. Three of a kind joker. The three of a kind. I think this one is slightly easier, right? You can have 1, 2, 3, 3 jack. So basically, if you have a pair, I'm pretty sure. The two pair one is weird because the two pair joker just can't exist. What I mean by that is if you have 1, 2, 3, 4 jack, joker even, this is a pair. If at any point you have a pair that you could combine the jack to make a 4 maybe, this is going to go into a 3 of a kind. So I think the two pair isn't actually possible. So I'm still going to write it and just return false. Actually just big return false here. We should never really like go into it, but anyways. And then the pair, well, the pair's just true if there is a jack. So the pair pair joker return true. Just yeah, that's it. Should be fine. All right. Tie breaks part 2. Yep. So now we need our get hand. Oh, okay. Get hand part 2, which is going to do, we're going to try 5 of a kind, or we're going to try 5 of a kind joker. Oh, should we try a macro here? I think we should. So we're going to find a space. Yep, we're going to yank inside the word, find the bracket, go into insert mode, paste the word, type in joker, cards, close brackets, 3 down, 3 up, find brackets again, find close brackets, or 3 down here. Alright, so no, although I really want that to work, so I'm going to try again. Here, find the bracket, go forward a word, yank inside the word, find that, or try joker, cards, 3 down, go like this. Look at that, very cool. Get hand part 2, okay. But basically now we're going to just do this again. Oh, this is so messy. We're making way too much stuff. Joker, 6, yep. Hands, joker, 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 joker. Yeah, this is where like not knowing the language all that well really comes back to bite you, because this is just not nice. Okay, if we go here, we tokenize, blah blah blah, get hands part 2 with cards. We don't do hands, we do hands joker, that append. And then we're gonna need you again. Six of this, yep. Oh god, not that. Slices, part 2. Joker, joker, find the comma again, joker, 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 joker. That's part 1. Oh, and then also we need to sort. This is a huge file. Nope. Find that again, joker, yep, and also tie break from input. Oh, we need to change that, don't we? Tie break from input to be tie break from input parts 2. Okay. Okay. Now, what we need to do is basically this same thing. Count it, go 1, part 2, part 2. This is not of R. It's gonna be slices part 2. Yeah, something like that. Okay. Did actually compile first time. That's great. But we get 0. And get 0. Have we got these right? Joker. Yep, Joker. Oh, hands. We don't want hands, we want hands to be. What do we want them to be? Hands, Joker, yeah. No way. There is no way. No way. I'm almost relieved. Like, can you imagine if that works? First try. This is I mean, I love admin of code, but this is a pretty bad example input. I'll say. It's probably hard to make a very good one, but this forces me to make one, which in previous years maybe not so much, but okay. It's okay. Let's make our own one. Oh, that means we have to make our own one. So annoying. Okay, king. You're gonna have a 2. You're gonna be the highest. You're gonna be there. Okay, just an easy test. The jack goes into an ace. You know what? Let's actually just tiebreak part 2. Tiebreak part 2. We reverse the jack if they're not equal and one of them is a jack. Then yeah, we return true and then return false. Okay, I think that's all fine. Okay, jack goes into an ace. For the second one, the jack can go into either A, but basically we should get this as the highest. 2 times 2 and 3 times 1, so 7. We get 7. Let's try some easy ones. 1, 2, 3, 4, 4 jack. 1, 2 jack, jack, 3. So 3 times 2 is 6. Plus 2 is 8. Yep. Should we try some tie breaks? So ace, jack, 8, ace, 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 jack, jack, jack. Both 5 of a kinds, but this one wins, so this should be 8 again. Ooh, not 8. Not 8. Interesting. Tiebreak part 2. Tiebreak part 2. Very interesting. Right, because this one wins here. Test tiebreak. Try expect tiebreak part 2 of ace, jack, ace, 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 and ace, ace, jack, ace, ace. I can't remember now. This actually returns. I don't know actually. Let's just hope. Let's see what happens. This one. Actually, we want false, I think, for that top one. And because that means the first one is bigger than the second one, like kind of weird, but we had to do it that way to make it into, I think, ascending order or something like that. This is yeah, we messed up the orders. But then this here, and let's just for consistency. Do this. This should also be false, but it's not, right? And the first one is stronger. Okay, why am I getting the wrong answer then? This one here is a big one, so 3 times 2, 6, plus 2, 8. Let me print 5 of a kind. 5 of a kind slice joker. Oh, it doesn't think that these are both 5 of a kinds. I don't think that top one is. Let's double check. 5 of a kind joker. Oh, okay. Yeah, that's not quite right. That's not just a 4 of a kind. It is if there is a jack and there is a full house. What if I change this to a, yeah, that works too. If there is a jack and a full house, or a full house, or the cards. Okay. Just because, you know, I'm hopelessly hopeful. Hopelessly hopeful. Was that the only error we had? Maybe? Incredible. That was the only error we made. That feels so good. What a day. And ends at exactly midnight. Wow. I'm like actually impressed. I did not think. I mean, it wasn't easy. It was a lot of code, especially in Zig. It was a lot of code, but like, wow. Yeah, the maths really helps. I might try and formalize it and actually put a little sketch on GitHub. It might be helpful. I might write a blog post about this one actually. I liked it a lot. Yeah, wow. Thanks so much for watching, and yeah, as always, I'll see you tomorrow.